So good afternoon to all.
Good afternoon, sir.
Yes, good afternoon. So morning class, we had a discussion on the purpose of the embedded system, and then we also went through the topics that we are going to discuss in the second chapter of module 3. So now today, so for this class, we'll try to understand the ports of LPC2148. Okay. Now these ports are necessary for making your LPC2148, so either to send the data to the external devices or to get the data from the external devices. Okay. Uh, what are the ports available in LPC2148 and how to handle those ports using the registers. Okay. So port handling registers. So these are the things that we are going to understand now, and this is very important. So this class is very important. So if you understand the concepts very clearly here, so then all the other lab programs you can easily understand. Okay. So after explaining the LPC2148 ports and the port handling registers, so we'll try to do one simple program, sample program, which is going to blink the LED. Okay. So that is what we are going to do today. Now, so LPC2148, low power controller 2148, is an ARM7, is a microcontroller which is based on the ARM7 design. Okay. And now how this LPC2148 looks. So the picture is here. So has 64 pins arranged in quad inline package. That means on all you'll find the pins on all the 4 sides. So people are able to say this. Hello.
Yes, sir.
Yeah. So there the pins are distributed, okay, on all the 4 sides. So quad inline package is this. So similarly, you get dual inline package. So ICs, integrated ICs, you have seen, I think, in the previous semester. So there, so pins were there on only 2 sides. That is dual inline package. So, but this is so quad inline package, since you find the pins across all the 4 sides. Okay, how many pins are there? 64 pins. Now, among the 64 pins, if you count all these things, it comes to around 64. Among the 64 pins, so 48 pins are general purpose input output pin. Okay, among 64, 48 pins are used as general purpose input output pins. So the 48 pins are available for taking the input to the microcontroller and also sending the output from microcontroller to the other devices. So 48 pins they can use for that purpose. Okay, so GPIO is nothing but general purpose input output pins. Okay, next. So if you want to make all this 48 pins to act as input pins, you can do that. If you want to make all the 48 pin to act as output pin, you can do that. Okay, and some as input and some as output, you can do that. So that is the reason we say they're general purpose input output pins. Okay, now again, so as 2 ports named as P0 and P1. So LPC2148 has got 2 ports. So one port is named as P0, another one is named as P1. Now port 0 has 32 pins. Okay, so port 0 has, it's a 32-bit port, has 32 pins. So numbered something like this. So the 0th pin of port 0 is represented as P0.0. So the first bit of, or the first pin of port 0 is represented as P0.1. So P0.1 says it is the first pin of port 0. P0.2 says it is the second pin of port 0. OP people are able to understand?
Yes, sir.
Okay, and similarly, the last pin of port 0 is referred as P0.31. Now, by looking into this, you can say it is a 31st bit or 31st pin of port 0. Okay, and similarly, P1 has 6. Sir, why sir this has 32 pins and this has 16 pins? Even P1 also has 32 pins, but the usable pins for the user in port 1 are only from P1.16 to P1.31. Okay, see what this says now, only the higher 32 pins in port 1 are usable by the user, can be used by the user, but the remaining port pins, that is P1.0 to P1.15, are not available for the user. So that means these port pins are used by the LPC2148 itself for some other purposes. Okay, and it will not allow us to use the port pins of port 1 from P1.0 to P1.15, and in port 1, so you can go for using the port pins P1.16 to P1.31. Is that clear? Hello?
Yes, sir.
Yeah. Now sum these two now. 32 plus 16. Okay, how much it is? 48. Okay, now this 48 general purpose input output pins are distributed across two ports. One is called as P0. In this P0, it is all the port pins from P0.0 to P0.31 are accessible by the user, but in the port 1, so user can access only the port pins from P1.16 to P1.31. So, but the port pins from P1.0 to P1.15 are not available for the user. Okay, so remember this. So it is a quad inline package. LPC2148 is in the form of quad inline package, and it has 64 pins. Among the 64 pins, 48 are general purpose input output pins, which are divided into two ports, port 0 and port 1. So port 0 has 32 pins, and all the 32 pins of port 0 are usable by the user. So the port pins of port 0 are numbered as P0.0, P0.1, P0.2 dash dash something like this till P0.31. And similarly, port 1, so only the higher 16 pins are usable by the user, that is P1.16 to P1.31, and the lower 16 pins are not usable by the user. Okay, with this we'll come here. Now, so pin functions. So I said 48 general purpose input output pins are there, and these 48 general purpose input output pins can perform other functions also. Now what are they? Generally, each available pins, that is 48, can perform 4 functions. So you have 48 general purpose input output pins, and each of this general purpose input output pin is capable of performing 4 different functions. Now what are they? So generally we call it as GPIO, but apart from this GPIO input output function, so they can also go for performing the transmitter or receiver function, pulse width modulation, and external interrupt. So we are not going to use so few experiments we operate it in the GPIO mode. Each pin, this 48 pins, each of this 48 pin can be made to operate in all these 4 modes or 4 functions. Okay, you can configure it to operate in GPIO mode. You can configure it to operate as transmitter or receiver. You can also configure it to operate in the pulse width modulation and external interrupt. So we don't discuss this pulse width modulation. So, but we go for making each of this 48 pin either to operate in the general purpose input output mode, or make it as transmitter or receiver or external input. Okay, this now say for example, I want to make P0.0. Can anyone tell what pin is this? Which pin is this?
Pin 0 from port 0.
Very good. So 0th pin of port 0. 0th pin of port 0. So I want to make this operate in this particular pin, operate as general purpose input output pin. Then what is that I got to do? I got to give the bit 00. So if I assign 0, 0, so then this particular pin acts as general purpose input output pin. Say for example, the same pin P0.0, I need to make it as a transmitter. Okay, then I have to use 0, 1. Okay, 0, 1. If this can only act as a transmitter. Okay, it cannot act as a receiver. So if I make it as 0, 1, so if this combination of the bit if I give, then the same pin of port 0, that is 0th pin of port 0, acts as the transmitter. Okay, and then so I want to make this P0.0 act as pulse width modulation. So 1, 0. Okay, and 1, 1 is not defined, so we don't have any meaning for that till. Okay, so not defined, let us not use it. So this is, so now similarly, say I want to make, say this P0.0 operate in general purpose input output mode, and say P0.1, say P, the next port pin P0.1, I need to make this function as a transmitter. What is that I have to do? I have to assign the value 0, 1 to this. So if I assign a value to 0, 1 to this, then we have this functioning as transmitter. Now where to assign these values? You still don't know. So till now you understood that among the 64 pins which are available within LPC2148, 48 of them are what? General purpose input output pins. And so all these pins, 48 pins, you can also make them to what? Perform other functions. What other functions? You can also make them as transmitter, receiver, pulse width modulation, and external interrupt. Now how to do those things? By assigning the bits. Okay, 0, 0 will make the corresponding pin operate in the general purpose input output mode, and then 0, 1 makes it as either transmitter or receiver, 1, 0 for PWM. Okay, and external interrupt is also there. We'll understand it next. Yeah, sorry, this is external interrupt. EXT INT, external interrupt. Okay, next, we'll come here. Say for example, I want to make P0.1, that is the first bit of port 0, to operate in the GPIO mode. Same again, see, 0, 0, GPIO mode. And this P0.1, say in while explaining here, I said P0.1, I want to make it at a transmitter. No, not possible. So P0.1 will not act as the transmitter. Only P0.0 acts as the transmitter, and P0.1 acts as the receiver. So if one is acting as the transmitter, the other one should act as the receiver. So P0.1 can be configured to the receiver. So if I give 0, 1, so we have P0.1 acting as the receiver. If I give 0, 1 to P0.0, it acts as the transmitter. And then PWM 1, 0, and external interrupt 1, 1. See, and again, so external interrupt for this P0.1 is not possible. Sorry, P0.0 is not possible. You cannot make this P0.0 act as an external interrupt pin. So, but P0.1 can be made as an external interrupt pin. Okay, like this. So to define the function of each port pin, you require how many bits? How many bits are required to define the function of each of 2 bits are required? Okay. Now, how many such pins are there? 48 pins are available. Okay. So to define the function of 48 pins, we need how many bits? 48 into 2, 96 bits are required. So define the function of one port pin, you require 2 bits. Now we have 48 such pins, and 48 into 2, you require 96 bits. So 90, if I want to define the function of all the 48 pins, then I should be using the 96 bits. Now from where will I get this 96 bits? I'll show you. So now we have something called as 3 PINSEL registers. Okay, so I need 96 bits. From where I'm getting this 96 bits? I'm getting this 96 bits from these 3 registers. So there are 3 registers with the name PINSEL 0, PINSEL 1, and PINSEL 2. So pin select 0 it is, pin select 1, pin select 2. Okay, so this are the 3 registers which we use in order to define the function of all the 48 pins. Okay, let us come here. Now, what is the capacity of each PINSEL register? So 32 bits. 32 bits. Okay, and how many such registers are there? 3 registers I have: PINSEL 0, PINSEL 1, and PINSEL 2. Now 32 into 3, how many bits you got? How many you got?
96.
96. How many were required? 96. So now, so these are the 3 registers which we will be using in order to define the function of each port pin. Okay, PINSEL 0, remember this. So port 0 and P0 and P1 are the ports of LPC2148. Now to configure these port pins, as GPIO, or as transmitter, or as receiver, or as PWM, or as internal, external interrupt. Now what I have to do? I got to make use of this registers. I can go for configuring the port pins of port 0 and port 1 to operate in a specific function by using these registers. Okay, now let us have a look into the PINSEL 0. Now, why it is named as PINSEL 0? Because it's used to define the function for the port 0 pins from P0.0. See, P0.0 to 0.15. Using PINSEL 0, it is only possible for you to define the functions for the port pins from P0.0 to P0.15. Why? Because to define the function of each port pin, how many bits are required? 2 bits are required. Now what is the capacity of this bit? This register 32 bits. Now using all the available 32 bits of PINSEL 0, you can only define the functions from the port P0.0 to P0.15. OP people understood? Did you get
Yes,
that?
sir.
Okay. Now say it is written here also. Say I want to make port pin 0. I want to define the function of the port pin 0.0. Now which are the 2 bits that I have to use from the PINSEL 0? So 0th bit and first bit. OP people are understanding.
Yes, sir.
And then to define the function of the P0.1, I got to make use of the second bit and the third bit in PINSEL 0. And similarly, if I want to define the function of P0.15, so which bits I got to use? 30th and 31st bit from PINSEL 0. Now, using the bits which are there in the PINSEL 0 register, you can only define the function from the port pin 0.0 to port pin P0.15. Say for example, this P0.8. So I want to make this P0.8 function as general purpose input output pin. Now what should be the value of the 16th bit and 17th bit in the PINSEL 0? Tell me. So what should be the value of 16th and 17th bit in the PINSEL 0? To make P0.8 operate in GPIO mode. I showed here. For GPIO mode, what is the bit 00? Hope people are following.
Yes, sir.
So others, please.
Yes, sir.
Okay. See, 16 is 0. Make this bit also 0 and this bit also 0. So if when you're making 16th and 17th bit as 00, we have this P0.8 functioning as what? Functioning in which GPIO mode, general purpose input output mode. Say P0.0. I want to make it as a transmitter. Now what is the bit sequence? So for making it as a transmitter, I got to use 01. 01. Now, so this bit, the 0th bit value must be 0 and the first bit value must be 1. So these are the bit values and these are the bit positions. This 0 is this is position and this is the first position. And next, say for example 0.1. So now we have this acting as a transmitter. Now 0.1 I want to make it as a receiver. Now what I have to do? Again, So the second bit I have to make it as 0 and the third bit I have to make it as 1. So here, see, where is it? Yeah, here. So receiver, sorry, it is 0 1. So I have made a mistake. 0 1 and this also 0 1. Okay, so if you give this bit sequence 0 1 2 in the pin cell 0 for the second bit and the third bit, now the corresponding port pin, that is P0.1, is acting as a receiver and this is acting as a transmitter, and this is in the operating in the general purpose input output mode. Hope you understood. Is that clear?
Yes, sir.
So this is we were going to write the program for doing these things. Okay, so that's the reason I'm saying, I'm insisting these are all the things which are very much important, and all you should get familiar with these things. Port 0, port 1, which are the port pins available in port 0 for the users to use, P0.0 to P0.31, and port 1, so P1.16 to P2.31 and P1.0 to P1.15. So they are not available for the users to use. And then there are 3 PINSEL registers available. Using PINSEL 0 register, you can go for defining the functions for the port pins P0.0 to P0.15. Okay, so now done. We'll come next. Similarly, PINSEL 1 register. Okay, so using PINSEL 0, you're defining the functions of the port pin from P0.0 to P0.15. Now, using PINSEL 1, you can go for defining the function of the port pins P0.16 to P0.31. Okay, similarly, see, same thing. So these are the bits of the PINSEL 1 now. Okay, now this using this bits of PINSEL 1, I can go for defining the function of the port pins P0.16 to P0.31. Okay, and similarly, so PINSEL 2 is used for defining the function of the port pins P1.16 to P1.31, and so P1.0 to P1.15 so is not usable by the user. So hence we don't have another PINSEL register for defining the function of those things. Got the point?
Yes, sir.
Now, if I ask you a question, which is the PINSEL register you'll be using in order to define the function of P0.27, which PINSEL register you'll use? In order to define the function of the port pin P0.27, which PINSEL register you have to use?
PINSEL 1.
PINSEL 1.
1.
So similarly, to define the function of the port pin P1.28, 1.28, P1.28, which PINSEL register you'll use?
2.
PINSEL 2. Okay, and similarly, so to define the function of the port pin P0.6, which PINSEL register you'll use? PINSEL 0. Remember this. PINSEL 0 is the register used to define the function of the port pin from P0.0 to P0.15, and similarly PINSEL 1 is the register that is used to define the function of the port pins P0.16 to P0.31, and PINSEL 2 is the register that is used to define the function of the port pins P1.16 to P1.31. Okay, now I have the examples here. So to make the P0.0, the port pin P0.0 to function as GPIO, what you got to do? Assign the 0th and the first bit of PINSEL 0 to 00 respectively. That is what I was showing. So this is this is 00. So similarly, this P0.0, if I want to make it operate in the general purpose input output mode, this is not the value I have to give. I have to give 00 in the 0th bit and the first bit of PINSEL 0. If I make it as 00, then we have the corresponding port pin P0.0 operating in the general purpose input output mode. Similarly, so to make P0.1 function as a transmitter, so this is what I had written earlier. Now I scratched it. 01 is the data. So make 0th and the first bit of the PINSEL 0 to 01 respectively. And then similarly P 1.16, 1.16. So this is port 1 16th bit. Which PINSEL register you have to use? PINSEL 2. So make the 0th bit and the first bit of PINSEL 0 to 00 respectively. To make P 0.28 to function as GPIO mode. So again 25th, 24th and 25th bit. P 0.28, right? P 0.28, where is it? Here. See, which are the bits for that? 25th and 24th. Make 25th and 24th bits of PINSEL 0 to 00. Sorry, I made a mistake here. Is it PINSEL 0 or PINSEL 1? This should be PINSEL 1. This is PINSEL 1. Did you get that?
Yes, sir.
25th and 24th bits of PINSEL 1 to 00 respectively. Okay, next. Okay, done. So you understood ports till here. How many ports are there?
2.
What are they?
Port 0 and port 1.
Port 0 and port 1. What is the capacity of port 0? How many pins are there?
32.
32 pins. How many pins are there in the port 1?
16.
32 pins. Again, port 2 also, sorry, port 1 also, you have 32 pins. But usable are only from
16 to
16 to 32.
yeah, P 1.16 to P 1.31, and the lower 16 pins are not usable. Okay, they are not for the user purpose. And then you understood the PINSEL registers, which are used to define. So if I ask you a question, for what you're using the PINSEL register? Answer my question. So for what purpose you're using the PINSEL registers?
So to set the function of pin.
Yes, to define or set the function of the port pins. Okay, done. Now we'll come here. Next is direction registers. See, direction registers are used to define the direction of the ports. There are only two directions possible for a port. So either a port pin can act as an input port pin or it can act as an output port pin. Okay. In other words, to define the port pins either as input or output. So we make use of the direction register. Okay, using PINSEL register, you define the function of the port pins. Now you got to define the direction of the port pins, whether you want the port pin to act as input port pin or as output port pin. Okay, now so we have two registers for that purpose. One is called as IO0 DIR and IO1 DIR. Now this 0 indicates, so this is the register associated with what? So this is IO, input output. This is 0. Let me put a line here. Don't confuse. IO0 DIR. DIR stands for direction. Now this register is the direction register for which port?
Port 0.
Port 0. It acts as the direction register for the port 0. And similarly, IO1 DIR acts as the direction register for the port 1. Okay. So that is what is written. See, IO0 DIR acts as the direction register for port 0. It is of capacity 32-bit again. And IO1 DIR acts as the direction register for the port 1, and it is also of capacity 32-bit. Okay. Now, say for example, I'm making the 0th bit of IO0 DIR. I have 32 bits. So in this 32 bits, the 0th bit of IO0 DIR, I'm making it as 1. What does it indicate? So if I make the 0th bit of IO0 DIR as 1, so it makes the corresponding port pin, that is P0.0, to function as So function we have already defined. So we are setting the direction of P0.0 to act as output pin. Output pin. That means, so if I set the 0th bit in IO0 DIR register to 1, so we have this port pin P0.0 acting as output pin. That means it can only send the data from the microcontroller to the external device that is connected. So the communication is happening from the controller to the external device. Did you get that?
Yes, sir.
Similarly, say for example, the 0th bit of IO0 DIR, instead of making it as 1, I'll make it as 0. Now where I'm making this 0? In the 0th bit of IO0 DIR, I'm not doing anything on the port pin. You cannot do anything on the port pin. In the register IO0 DIR, I make the 0th bit as 0. So then the corresponding port pin, that is P0.0, is not acting as output pin. Instead, it is acting as input pin. That means it is input pin. That means it takes the data from the external device to the microcontroller. So from an external device to the microcontroller, the data comes in. The data comes in to the microcontroller. If you make it as an output, the data goes out of the microcontroller. Is that clear? Did you understand?
Yes, sir.
Okay. So remember this, that this also you have to remember. So in the direction register, if you make any corresponding bit inside the register as 1, so the corresponding port pin acts as the output. 1 means output, 0 means input. Remember this. Okay. 1 is output and 0 means output. Sorry, input. 1 is output, 0 is input. Now to remember, see, I remember it always like this. Output, it is O right, and input I right. So opposite of this, that's all. So if O is there, it is input. Sorry, 1 is there, it acts as input. So 0 is there, it acts as input. Okay, next. So you can easily remember opposite of these two things. Okay, 0 O means output, right? So if you instead of 0, if you write it as 1, it is. So for 0, you got to write it as 1. That means it acts as the output. For input, 0. Next. Okay. Remember, whichever way is convenient to you, but I have my own way of remembering it. I remember it. Next. Okay. Now I want to make all the pins of port 0 to operate as output pins. All the bits I need to make as output pins. So P0.0 to P0.31, all the 32 pins I got to make them as output pins. So that means I want to make them carry the data from the microcontroller towards the external device that is connected. Now what is the data that I need to assign to IO0 DIR? Which register I got to make use? Which direction register I have to make use? Hello? What is the register that I have to use? To make all the pins of port 0 to operate as output pins. Which register?
IO0 DIR.
IO0 DIR. And see what is the data I'm assigning? FFFF. FFF in binary is nothing but what? 11111. All 32 bits 1. Now this one, which is in the 0th position, okay, this is at the 0th position, this is at the first position, this is at the second position, and this one is at the 31st position. Now the bit 1, which is at the 0th position in IO0 DIR, what it will do, it will make the corresponding port pin, that is P0.1, to operate as input or output. 1 means output. So now P0.1 is acting as output. So P0.1, sorry, P0.0 is acting as output. P0.1 is also acting as output, and all the 32 port pins of port 0 are acting as output port pins. Okay, next. Now to make all the port pins of port 0 to operate as input pins, what is the data that I need to assign? I got to make all of them as 0. So IO0 DIR is equal to 0x this time. Hope you understood.
Yes, sir.
Okay, next. So now, so here I understood how to make all the port pins of port 0 operate as output pin, and here I understood, we understood how to make all the port pins of port 0 operate as input pins. Now I don't want to make all of them. So example, to make only the port pin 0.0 to P0.3 of port 0 to operate as output pins. Only from P0.0 to P0.3, I need to make them as what? Output pins. Now what is the data? So this is the data. Now this 0000F, if I write in binary, this is what the data I'm getting. This is what the data I'm getting. See, 1, 1, 1. So this one will make P0.0 operate as output pin, and the next one is making P0.1 operate as output pin, and this is making the next pin P0.2 operate as the output pin, and this bit is making the P0.3 operate as output pin. Did you get that? So
Yes, sir.
we
Yes,
have
sir.
only these 4 port pins functioning as output pins, and what about the rest all? All these things are functioning as input port pins. Okay, now to make only P0.1 of port 0 to operate as output pin, so this is the data. This is the data I need to assign to the IO0 DIR. Now doing this thing, we call it as what? Programming. Okay, so I got to assign this data to IO0 DIR in order to make only P0.1 of port 0 to operate as output pin. So if I'm writing this in the binary, see, this is what I got. 1 in what position? In the first position, and this bit is going to make P0.1 to function operate in as the output pin, and the rest all, so all these things and including this, they're acting as input pins. Okay, next. Now how do you make all the pins of port 1 to operate as output pins? Okay, let's see, like this. Now instead of assigning it to IO0 DIR, we got to assign it to IO1 DIR. Now we have all the pins of the port 1 operating as output pins. So similarly, I want to make all the pins of port 1 to operate as input pins. So assign 0, 0. So but the lower 16-bit is not usable, okay, by the user. But this is not, even if you assign 000 complete 00 to IO1 DIR or FFF to this, for the lower 16-bit it doesn't have any effect. So the lower 16 bits you can identify, so it doesn't have any effect. But the higher 16 bits is going to make the P1.16 to P1.31 function as, so if you're assigning 111 output pins, and similarly here these things are going to make the P1.16 to P1.31 to function as input pins. Next. So for example, to make P1.0 to 1.3, this is not possible, but just as an example I've taken, because P1.0 to 1.3 you cannot use. So what you can use is from P1.16 to P1.31. So just for an example, that's all. What this is the data, and it makes. And only to make P1.1 of port 0 to operate as output pin, this is the data as we understood. So just for the sake of taking the example I've taken, but strictly speaking, so you cannot operate or use these port pins. Okay, not possible. Now, so first you understood the ports, port 0, port 1, capacity you understood, which is usable and which is not usable you understood. And after that, you understood the functions of the port pins, and you understood the registers, 3 registers which are used to define the functions of the port pin. So PINSEL 0, PINSEL 1 and PINSEL 2. And next you understood the direction registers using which you can make the port pins either as input pin or as output pin, IO0 DIR and IO1 DIR. Next is port pin set registers. So if I want to set the value on the port pin, okay, how do I set? So for that purpose, we have the registers IO0 set and IO1 set. Now what is this IO0 set? IO0 set is the register which is associated with the port 0, and this is the register which is associated with the port 1. Okay, now to set all the pins of port 0. So on port 0, P0.0 till P0.131, I need to make all the port pins I. Then what is the data I got to assign? So in IO0 set, I got to take this data. Assigning this data in the register IO0 set will make all the corresponding port pins P0.0 to P0.31 will take the value what? High. So people are following? Hope people are following?
Yes, sir.
Yes,
Say,
sir.
no, I'll take an example. Say this is my microcontroller. It has two ports. This is one port and this is another port. Okay, this is P0 and this is P1. Okay, let us assume. So all the port pins of port 0, I made it as output. And this port is connected to say LEDs. So I have 32 LEDs here. Dash. These circles are the LEDs. Okay. Now what this? So when I take this data, IO0 set is equal to 0 FFF assign. Now what it's going to do? It's going to make all the 32 port pins of port 0 send the I value, that is the value 1 to the LEDs. Now all the 32 LEDs will glow. Hope you understood. What is the direction in which the data is flowing? From the microcontroller to, let me write it as MC, microcontroller to these LEDs. Why? Because P0 is configured as output. P0 we have made all the port pins of port 0 to operate as output. So the direction of data flow is like this. Okay, understood? Hello?
Yes, sir.
Yes,
These
sir.
are the values. So this is the value of the port pin 1, port pin 0. 0.0. This is the value of the 0.1, 0.2 like this. So if you set FFF, in IO0 set, so now the corresponding port pin gets the value high. Okay. Example to set all the port pins of port 1. Okay. So this FF. So port 1 again it is set high. Next. Now to set only the pins P0.0 to 0.3 of port 0. So this is the data, same data. Okay. So this is going to make only, so you have the value 1 on port 0.0 to 0.3 and all the other port pins of P0 you have the value 0. Okay. Next. So to set only P0.1 pin. So I want the value 1 on only P0.1 and the rest all should be 0. So this is the data. Next. So similarly for IO1 set. Okay. So this is the data. So if I want to set only these things, this is the data which is setting. And if I want to set only this port pin, so this is the data. Next. So after IO set, so sometimes we need to clear the value on the ports also. How do I clear? See, IO0 CLR, IO1 CLR. IO0 set will set the corresponding port pin. IO0 IO1 sets the corresponding port pin on port 1. Now similarly IO0 CLR clears the corresponding port pin on the port 0 and IO1 CLR is going to clear the corresponding port pin on the port 1. Okay, now how do I clear all the port pins of port 0? See, IO0 CLR 11. See, it's not like you have to assign 00 to clear. You assign 111 to IO0 CLR. This register itself is clear. Assign 111 to IO0 CLR. So the value of FFF in binary is this. What it is going to do? So it's going to make all the port pins P0.0 to 0.31 take the value low or 0. And similarly, to clear everything on the port 1, so this is what the data, same data we assign it to IO1 CLR. And similarly for clearing only the port pin 0.0 to 0.3, this is the data. Only thing is earlier to set we were assigning it to IO0 set. Now we are assigning the same data to IO0 CLR. Okay, and then another example. So again, one more example here. And then example to clear only the port pin P1.1. This is the example. Okay, next. So I guess you people understood. How many registers we understood now? So let me summarize. First we started with the ports. Two ports, port 0, port 1. Port 0, all the pins are usable. Port P1, so you can only use upper 16 pins, P1.16 to 1.31. And then so we looked into three PINSEL registers, PINSEL 0, PINSEL 1 and PINSEL 2. PINSEL 0 is used to define the function for the port P0.0 to P0.15, and PINSEL 1 is used to define the functions of the port pin P0.16 to P0.31, and PINSEL 1 is used, sorry, 2 is used to define the functions of the port pin P1.16 to P1.31. Clear, right? Please respond.
Yes, sir.
And then direction registers we understood, IO0 DIR and IO1 DIR. Okay, so using this registers, you can make the corresponding port pins of port 0 or port 1 either as input or output. And then we looked into the IO0 set and IO0 CLR. Okay, IO0 set, IO1 set, and then IO0 CLR, IO1 CLR. These are the registers which you should be very much familiar. Okay, and the same registers will be using throughout. Now example 1. So I want to write a program for blinking the LED. Okay, now let us connect. So what I'm assuming, any pin you can take. I'm taking the port pin P 0.9. Okay, so LED connected to P 0.9. I'm connecting the LED to the port pin 0.9, and to make 0.9 operate in the GPIO mode. So 0.9, right? Now I want to make it operate in the GPIO mode. What is the data I have to give? 00. So and 0.9 to make the 0.9 operate in the GPIO, which register I have to use? PINSEL 0, and I'm making 00. All the port pins from 0.0 to P0.15, they are operating in the GPIO mode, and P0.9 is also operating in the GPIO mode. Next, make P0.10 act as the output pin. Okay, so IO0 DIR, this is the data I'm taking. Okay, so because I want to make the P0.10 act as the output pin, so this if you write in binary, so this bit 1 comes exactly to this position. Now repeat forever the following steps. On LED by writing 1 to the 9th bit of IO0 set register. So this is what the data, and call it delay of the LED by writing 1 to the 9th bit of IO0 CLR. Okay, now the moment I write 1 to the 9th bit of IO0 set, what will happen? This is not 10, 9, because I have got to make it as output pin. Okay, P0.9 is the one which we are using, and then writing 1 to the 9th bit of IO0 CLR will make the LED go off. Now this is the program. Look here. So try to understand. So this is what the header file you got to include, LPC21. So I'll execute and show you this. And I'm calling the delay. This is the C program. Say PINSEL 0. So all these things, PINSEL 0, IO0, DIR, all these things you can use only if you include this header file. So LPC214 xx.h, because the same header file applies for other microcontrollers are also which are starting with the series 21. So pin cell 0, this is what the data I'm assuming, assigning. What it is doing, all the port pin P0.0 to 0.15, they are configured to operate in what mode? GPIO mode. And next, I want to make only the P0.9 as the output pin. So this is the data. So write this in binary, it will make P0.9 act as the output pin. Now after this, I'm calling while, so infinite loop, and inside the while loop, so I need to set the value I on port pin P0.9. How to set the value I on port 0.9? So by using IO0 set, and this is the data. Now we are writing 1 to the 9th bit of IO0 set. Now when you write 1 to the 9th bit of IO0 set, the corresponding port pin P0.9 will go high. And it is already configured to operate in the output pin. Now this I value goes from the microcontroller to the LED that is connected to P0.9, and the LED glows. And I'm calling a delay because I want to make LED glow for certain amount of time, right? So I call this delay, and here I have a for loop which is just iterating for 95,000 times. So I'm spending some time, that's all. And then after a for loop iterates for 95,000, I come back. Now assign, I got to write 1 to the 9th bit of IO0 CLR. Writing 1 to the 9th bit of IO0 CLR will bring down the value on the corresponding port pin P0.9. So the value is reduced. Okay, and value becomes 0. Now the LED which is connected goes off. OP people are understanding?
Yes, sir.
Okay, now quickly let me execute. So because time is not there to show the circuit and all, tomorrow I'll show you. I'll go for running it. I've already kept it open. I had kept it open, I don't know. Oh, I've closed it. Let me open it again. Just a second. Oh, the program is here. See, this is the program. Now how to compile, and I'll show you. See, so this startup.s is required for this. Tomorrow I'll show you from the beginning, but today I'll just execute it and finish it. Say this has created an X file. So creating an X file. So X file is created. So let me go to the drive. We'll make it fast. Bit files. Samples. So blinking LED. X file. See, blinking LED.x file. This is the one which I need to burn. Okay. Now let me minimize this. So in Protest I've already created the circuit. I'll just show you. Again to my Google Drive, bit files, Protest simulation, LED blinking. I'm opening this. Let me open. So tomorrow I'll show you how to rig up all these things and do it. And I'll also share you the basic circuit. I'd kept it open. I think accidentally I've closed it. Yeah, tell me whether you understood all the registers and their use.
Yes, sir.
Yes.
Okay. Taking more time to open. So for this reason only I'd kept it open. I don't know when I closed it. So taking too long to open. Okay, no issues. We'll do tomorrow because the time. So tomorrow, let me explain the program once again and go for it because it is taking a lot of time to open. Let me check it tomorrow. So tomorrow I'll keep it open before I start the class, and I'll show you. Okay. So let me stop recording.